Chapter 12 talks about, let me here, there you go, minimize it like my friend. So, talking about chapter 12, guys, we'll talk about lighting branch circuits and small appliances circuits for kitchens. And just FYI review, we are familiar with this. In a kitchen, let's talk about requirement for the kitchen. Number one, you need how many circuits dedicated small appliances circuits? Two, at least. Can I have five? Be my guess. At least two small appliances dedicated for all the receptacles only in the kitchen. These two have to pass through the countertop. They can't be one in one side and the other side. The countertop will have one circuit. They have both of them have to go through the countertop. The lighting in the kitchen have to be in its own dedicated circuit. Cannot be mixed with the receptacle circuit, right? It could be mixed with other lighting circuits somewhere else, but it cannot be mixed with the small appliances circuit. Can I feed anything from the small appliances circuit that's not related to the kitchen, the dining room? Like a receptacle outside, steel, and feed the receptacle outside? No. So we all know that one. Here's what we're going to be talking, guys, about basically the kitchen, the dining room, and I'm going to jump. There's a few things also that it'd be nice if we set my marker. There we go. So I can mark these. All right. Next. Let's go through the adjustment stage here. All right. Let's see where we're in. All right. Now we're in. Okay, let's go back. It's a detour. Our detour. Okay, so we're going to talk about, guys, the exhaust fans. We know about the lighting and the receptacle in the kitchen. We're going to talk about the exhaust fan. What do we do with an exhaust fan for the kitchen? Do you feed it from the 220 amp dedicated circuits, or do you feed it from a dedicated circuit by itself? Do we feed it from the two small appliances? The exhaust fan for the kitchen. Exhaust fan for the kitchen, you're going to provide a 15 amp or 20 amp dedicated circuit for the exhaust fan in the kitchen, if any. If any. Small appliances circuit, we said we need at least 20 amp. How many of them? Two. At least 20 amp. And how many of these we're going to need? We need two. Moving on. A couple of things, guys, we'll talk about also the GFCI. What's the requirement for GFCI in the kitchen? All the receptacles on a countertop, all the receptacles in the countertop in the kitchen have to be GFCI or GFCI protected. And we have a really nice example about GFCI protected. The NEC code book allow you the Miss refrigerator to give it its own 15 amp dedicated circuit if you choose to. Can I put the fridge on the 220 amp circuits in the kitchen? Be my guest. Do you have to do that? No, you don't have to do that. Multi-wire branch circuits. Multi-wire branch circuits. I know I have a couple of electricians here. Multi-wire branch circuits, guys, can save you money. There's a few wiring diagrams that I like. When I wired it, I used it all the time. 12-3, you bring it with two circuits, use the neutral. So we'll talk about the multi-wire circuits with the split receptacles, and passing that multi-wire circuit, guys, through the countertop, feeding multiple receptacles through GFCI and another set of receptacle to another GFCI. We have a really nice picture in a second here that we're going to be going over. Okay, so this is where I'm going to spend some time, guys. This is how they designed the lighting system in this kitchen. The lighting system in this kitchen. So we have, you don't have to do it this way, but this is one way of designing it. As you can see, we brought a circuit number 7 over here. And why do we have 2 wires here, Spencer? Bringing the circuit with 2 wires. What are these 2 wires? A hot and a neutral. That's easy question, huh? What do you guys think these 2 wires going to the can through a switch? One is a hot, one is a neutral, always a neutral. What's the second one? Switched hot, thank you. And then we brought the power to this can, and we brought the power to this can, and we brought the power also to this light, as you can see, and we went through a 3-way switch. What they want to do, you can do anything you want with the switches, but what they want to do, guys, there is a track light over here, and they want to be able to, don't look at this section. This section has to do with somewhere else, but these 2 3-way switches are to control this light from 3 locations. So if I ask you, what are these conductors, 3 conductors between the 3 switches? 2 of them are travelers, and the other one is switched hot. The other one is switched hot. The other one is switched hot. So we have, why do we have 3 wires here? Why do we have 3 wires here? Let's count them. We have a hot and a neutral sitting right at this track light. So the neutral goes to the track light, and the hot moves all the way down to be switched and come back as a switched hot. As a switched hot. Come back as a switched hot, which is carried from right in here, right? We know between 2 3-way switches, we know 2 dedicated, 1 hot, 1 switched hot. 1 hot, 1 switched hot. 1 hot. One of them will be bringing the hot to the switch. The other one will be bringing the switched hot back to the fixture. Okay. And then we have a switch. 1 switch. Can you guys see that little switch here? That little switch. You can switch the fan. That fan from this switch. You can do it anyway without telling you guys. You can switch this fan. And what do you think the fan and the lights? I believe they're all in the same switched, in the same switch. That's why we brought 3 here, 1 hot, bring the hot here, bring it back, switch, and dump the hot across the fan and the 2 lights. Any question, guys? No? I see.
I'm curious, because if that's a light, doesn't it need to have a neutral on the light?
Yes.
And a hot, so why is it only 2 wires?
Let's switch
That
one.
could only be controlling the, well, you said that you could control the fan from there, so.
Yeah, one is a neutral, and the other one is, it could be the switched hot carried from here, from the fan, right? This little one, this
You'd have
one,
to have 2 hots, wouldn't you?
The lights are switched from another one.
the fan,
They're switched from the other one.
Yeah.
the light are,
Oh, no,
these
they're not. Because it had to be a 3-wire.
these 2 lights, this switch guy is switching this light, right? Let's just look at this, okay?
Correct.
Now these 2 lights and a fan, I believe they're switching in from 1 switch.
Well, wouldn't you have to control the fan from the fan then, because you would need a hot, you'd need a neutral and a
Okay,
switch
here's,
hot.
let's follow what's here. Do we have a neutral coming to this light?
Yes.
Yep. Do I have a neutral here?
Yes,
Do I have a neutral here?
yes.
I have one wire left. Now I'm bringing the hot. The other conductor will be a hot. Came over here. Also the hot now is coming over here. Coming over here, being switched and carried over through the second conductor and dumped through the third conductor to this one and through the second conductor to that light. I don't know if that's how they wired it, but that could have it.
Yeah,
So,
kind of
so the
dumb.
2 lights in the fan always come on at the same time?
I think that's that's the plan on that one. Any other ways of doing it? The hot, the fan, just the pull chain.
Well, I guess I think when I'm looking at that, but that's how it would have to be, is that you'd have to control the fan. from
It
there.
could be if you want it to be. It could be if you want it to be.
Who drew these things? It's just
Looks
like,
like a fan, looks like a light, yeah, oh yeah.
You look at the other plans, it's the exhaust,
Is it our exhaust fan? It's not a fan on the.
and that switched on by the 2 ways that you're talking about is the timer switch.
This switch. These 2
No, the
switches
one
are
next
for
to
the.
The one next to that,
Single pole.
the single pole switch, no,
This one.
that one.
Okay, so that's for what?
Timer switch, exhaust.
Timer switch. For how do you switch these 2 cans?
Mine, those are what 3 ways.
With the 3 ways? Is that what we want? Okay. So this, you guys, if we don't know what their intention is, really, looking at this layout, you can wire it, right? You can wire it any way, shape, or form you want. the intention is to have this as a dimmer switching, not dimmer, as a speed control to the fan, and then everything else will be fed from the three-way switch. Which does it work if we do it this way? Do we have a neutral? We have a neutral. Do we have a switched hot from here? Yep, we can have a switched hot and switch the two lights only, the two lights only. So the two lights only. A lot of crossing, huh? Cross. Any question, guys, about that? You really, with the layout, you can wire it anyway. You have to decide though ahead of time. Huh? Still has to work. Yeah. Definitely still have to work. We have our switch, three-way switch, two dedicated, came up to here. Okay, we bought the light here, the fan. We brought the switch to control the fan, one switch, and these two lights could be switched from the three-way switch. I guess it could work, no? With a three-way switch controlling the two lights and the fan controlled by this. So I have the neutral, the hot came over here. We switched the hot and we dumped it across this fan, so this is working. Then the hot came over here, and then so this switch needs two wires. I brought the two wires here to this switch. The switched hot came here. I carried the neutral from here, and another hot back. There's a lot of zigzagging. You guys want to wire it? We'll do the wiring. I think we have a layout of wiring it. Anybody? Do you guys agree with the design? Do you want more, less? No? A lot of zigzagging. What worries me about the can? What worries me, guys, about the can? Look at this can. If it doesn't have a box with it, you're using the can to pull the circuit to the fan, and you cannot use it if it's not dedicated to the same. This fan and this light, you can argue they have nothing, two different equipments. Now you're using the J box with the fixture to pull wires into the fan. Might not be the best scenario. And the same.
I think you said you couldn't use that as a junction box.
You cannot use it unless it's directly related to the lighting system. Is the fan directly related to the lighting system? No. That could be right here, could be a violation pulling the circuit, versus what the option is coming directly from here to the switch, right? Directly from here to this.
And why wouldn't they do that? Because you've got power at the switch.
They can. You can. You really can. You can come directly. You're just saving wires. You're saving wires. Then you have to have two wires over here, and coming and going up through the ceiling twice with two cables, versus going through with one cable up the ceiling and tabbing from the light into the fan in the ceiling. Any question, guys? We'll get to that one when we do wiring. All right. Let's get into the receptacle. Receptacle is easy. I want to bring your attention, guys, to how many circuits do we have in this. By code, you need how many? You need two. Do we have two? Let's count. Here's a one, and here's a second one. The second thing you're going to ask yourself, do these two circuits, do they feed loads on the countertop? Both of them. Yes, right? Both of them have fed loads on the countertop. Both of them. Good. I stole one for this is the Peninsula. If it's one by two, you need a receptacle. So here's my receptacle over here for the Peninsula. And what is this? This is for the refrigerator. Could I have fit this fridge from the same 2 20 amp circuits? Yes, no problem. They decided to bring a dedicated circuit for it. Is this an extra circuit over here? Could I have gone away with only 2 circuits in this area versus 4? Yes. Is it a good idea to add another 2 circuits? I think so. If it's my house, if it's your house, I don't think so. Is it a good design? Yes. A really good design to give more than what the code is asking for. Okay, GFCI. How would you do the GFCI, guys? So this one will be a GFCI. How about this one? Would this one be a GFCI? Yeah. Does this need to be a GFCI? No. This has to be a GFCI. Does this need to be a GFCI? Does this need to be a GFCI? No. So you only two receptacles GFCI. The rest of them are regular receptacle protected from a GFCI. How about these? Do these need to be a GFCI? No. How about this guy? Does it need to be a GFCI? No. Any question guys about this circuit? Any question about this circuit? Okay, now the 220 amp, these have to be 20 amp each, two of them, at least, right? This has to be a 20, and this has to be a 20. The rest of them, could they be anything? They could be anything. They could be 15 or 20, at least 220 amp circuit, at least 220 amp circuit. That circuit could be 15, could be 20, this circuit could be 15, could be 20, but at least 220 amp circuits.
Does the refrigerator receptacle, does that have to be just a single receptacle, or can it be?
It could be a single or duplex receptacle. Yes, sir.
That, like, kind of an example of that receptacle, like next on the wall, next to the sliding glass door. If that were to be within so many feet of that sink, would it have to be GFI protected?
If it's within 6 feet of the sink, if it's within any receptacle within 6 feet of a sink, has to be GFCI protected. That's a good point. Does it have to be protected if it's within 6? If this receptacle, guys, is within 6 feet of the sink, within 6 feet of the sink, right here, does it have to be GFCI protected? The code says if you have within 6 feet of a sink, doesn't say where the sink is located. Does it? Doesn't say where the sink is located. I hear.
This is laundry utility and wet bar sinks.
Okay, so it's specified exactly in these locations. Read the language again.
Laundry utility and wet bar sinks or receptacles are installed
Okay.
within 6 feet.
So the kitchen is excluded. Laundry, utility, and whip bars. So in a case like this,
Number 7.
then it's excluded. Does that make sense?
I know that I got.
Yeah, nailed.
Yeah, I got nailed on one of them. One.
Which were we?
It says
10.8,
on-
number
it
7.
says 5,
Within the
sink
8.
in the back on number 5.
But that's for non residential.
Unfinished basement. Receptacle? 5.
Says right there, sinks or receptacles installed within
Just
6 feet.
everything is in it.
Kitchen bay.
Bathrooms.
Plus bathroom.
Other than dwellings.
that's-
You're looking other than dwellings.
Everything.
This is a dwelling. You're right. Any sink, that's where the confusion is, guys. Any sink need within any receptacle within any sink, 6 feet need a receptacle if it's non-residential, other than dwelling. Sinks where receptacles are installed within 6 feet of an outside edge of a sink, you need a receptacle. No? Any question, guys? So long story short, in a residential, this doesn't have to be GFCI. It's not a laundry. It's not a laundry. It's not a wet bar. And what's the third one? And it's not the laundry and utility. It had this kitchen being a Dunwoody here, within 6 feet of a sink, you need a receptacle.
Does it
You need a
specify-
GFCI because it's not residential. Yeah.
Yeah.
Okay, moving on to, so we talked about the 220 amp small appliances circuit. The only thing I want to bring, guys, we all know that one. As we move through the load calculation, I want you to understand by code, you allow every 20 amp circuit, guys, have to be given an allocation of 1500 volt amp. 1500 volt amp for every small appliances circuit, meaning if you have two of them, multiplied by 1500, that will get you a 3000 volt amp as we guys calculate our volt amp for the sizing the panels and the main panel as well as the sub panels. And this is where we said the countertop must have the two small appliances passing through the countertop. Any questions about this? Two circuits, 1500 volt amp each. Next week we're going to be doing the load calculation. And Spencer, you're going to hear Chad saying you multiply 1500 volt amp by 2. because of the two circuits that we have in
Are you
every.
gonna go over
Okay.
that?
Yeah, we're gonna the load calculation, guys. We're gonna take a complete example from A to Z how to do load calc. We're gonna come to this one. We talk about the GFCI. Very good example, the sink. Very good example, Mr. Boo. The sink. If it's a sink within 6 feet of the kitchen sink, you don't need. If it's not on the countertop, you do not need it to be GFCI. Very good example. Additional small appliances circuit. Bring it on. You can bring as many as you want or as you need. This just some information, guys, about our friends, the mechanical contractors, info about the mechanical contractors and kitchen exhaust filter, filterless, ductless. You can read it on your own time. Long story short, if you have a fan, the only thing you need to do, if you have your fan, the best design for a fan and exhaust fan is to give it a dedicated circuit, 15 amp dedicated circuit, where you need a controller to control the fan, and call it a day. 15 amp dedicated circuit for the exhaust fan, and with a controller, of course, to control it. Most of these are hardwired control on the side, so you just dedicated hardwired circuit. Any question, guys? Any question about the fan? You have a fan, dedicated circuit, 15 amp at least, or 20 amps, and move on. Split circuit receptacles. I have a couple of examples, guys. A very good way of doing. You don't have to do it, but it's a very good example. And we used it in the project. If you have a split circuit receptacle, here's a split circuit receptacle. You feed and you bring the circuit to this receptacle. 2 circuits and a neutral. 2 circuits and a common in neutral. And from here, you feed one equipment. From the other side, you feed a different equipment. Dishwasher, garbage disposal. We've done it. And then this circuit will be 3 number for 12 AWG fed from 2 20 amp circuits tied together. So you bring the circuit here, you tie it together, and you land them on a switch, top, bottom. One goes to one side, the other goes the other side. Any question, guys, about the multi-wire split receptacle, duplex? One circuit goes to the top, one circuit goes to the bottom.
It matters which one's on top, right? Or does it not matter? The one after it's hot is on top, or
You probably
I
say
thought I
that,
read something
yeah,
that
they
said
want you,
the common practice is putting
the switched one at the bottom, I believe.
okay.
Switch one at the bottom, because you switch it and then allows you, the top is the hot. Common practice, not good though. Common practice. Okay, the 2 hots multi-wire branch circuit have to be landing on 2 poles, as we all know, right? Can you land it, multi-wire branch circuit, can you land it in 1 pole? 2 poles tied together. Here's a very good example, guys, of multi-wire branch circuits. Multi-wire branch circuit, the voltage between them is 240 here, and the voltage between any two is 120. So you pull your conductors, most likely it's going to be 3 conductor number 12, with these are 20 amp circuits, sharing a neutral. Common practice. What do you do if you do it this way? You saved yourself how many conductors? 1 conductor, right? And you balance the load. We'll talk about wiring. Wiring and continuity. If you're using a multi-wire branch circuit, only if you're using a multi-wire branch circuit. Because that's very common practice, guys. You can't stab the receptacles from the back, neutral in, neutral out, hot in, hot out, and move on. That's okay if you're using 1 circuit. The multi-wire branch circuits, you can't. So what do you need to do? You must splice and pigtail the neutral. You cannot bring the neutral to one side, the other neutral to the other side. The reason behind, anybody knows what the reason behind this?
You would lose the neutral.
The continuity of the neutral, multi-wire branch circuit neutral should not depend on the device. Because if you are to maintain this device and you take this device for service, what happened to the multi-wire branch circuit? You lost the neutral. What happened if you lose the neutral? You burn a few plasma TVs and a few refrigerators. and microwaves, right? Only if you have multi-wire branch circuit. If you don't have a multi-wire branch circuit, no problem. Stab in the back, stab, 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 and move on. That's the easiest way, guys, for especially for number 14 conductors. Stab them in the back and move on. Any question, my friends? Anybody has any question? Questions? I think that's all what we have. Escape. I have a couple of pictures. That I like. This is number. Let's go back to number 12. Okay, here's a circuit that we had an argument over. A couple of pictures, guys. I'm just going to go through about the installation. Sink, we talked about the sink. If you are within 6 feet of a laundry sink, what's the other one? Wet bar sink or utility sink, you have to have a GFCI. Other than that, no problem. We talked about this, multi-wire. Here's a very good installation. I like this picture, guys. Here's how two ways of feeding your light, bringing your two small appliances circuit. You bring a multi-wire circuit, which is will be 312 in this case, 312 for the kitchen. These are my two small appliances branch circuits. You bring them here, you share the neutral, you splice the neutral, you take one neutral to one GFCI on the line side of the GFCI. The load side of the GFCI, you feed the rest of them. Look how we splice the neutral on the line side of the GFCI. Mistake number one, splicing the neutral on the load side of the GFCI. So we splice the neutral. I want to emphasize this here. We splice the neutral on the line side of the GFCI, and we took the neutral with the other hot and we fit another GFCI and the GFCI protected equipment. Everybody knows that from here down, this is GFCI protected, right? And from here down, GFCI protected. GFCI protected. And where's the line side? This will be line, and this side will be load, right? And when you open the GFCI, it shows load and line. Mistake number one, bringing the line to the load, and the load to the line. Mistake number two, mixing, taking the neutral from the line, mixing it with the neutral from the load, malfunction. So that's how to use a multi-wire branch circuit as two small appliances circuit, with the two small appliances circuit in the kitchen. Any question, guys, about that? It will save you. Why this is a good idea? It save you money. Now you're using a neutral, one neutral versus two neutrals, and you're balancing your load too. You're balancing your load better. Any question, guys, about that? Where's the ground? Are we showing the ground? The ground, if you have a ground, of course, your ground is going to be landing here, and here, and here, and where's the other one too? In this area, this area, this area. The ground is going to be tapped. Ground goes with everything. Tapped, no problem. Any questions about GFCI multi-wire circuit used as small appliances circuit? Moving on to receptacles, go that one. Quick wiring exercise, load side and line side, load side and line side. If you want to bring your hot here, I use the wrong color with that one. So you bring your black right to here, and then from the other side, this is going to be where's my ground? To the other side. So this is the load side, right? So I brought the hot to the line side. From the load side, I took the hot to the GFCI protected, the neutral My neutral, guys, comes to the neutral. My other neutral comes back to the other side. Forget about the ground. So here's a GFCI protected receptacle. I need to share the neutral, so what do? They're coming to a J box. Is that J box, right?
Yeah.
That's the J box. They're going through a J box. So I bring my hot to the J box, and I'm go grab it and move it to the line side. From the load side, I'll bring it to the hot. And what do you think the neutral is going to happen? From the neutral, I want to go to the neutral side, to the load side, and from the line side, I'm going to go all the way and tap the neutral right here. So I have two GFCI receptacles feeding multiple things protected from them. Very typical application for kitchen. Very typical application for kitchen. If I have a third one that I need to throw here, piece of cake, just tap from here. The ground goes to the ground, right? All the grounds will be tied together, no problem. Mistake number one, mixing the line on the load side of a GFCI. If you guys haven't wired them, that's mistake number one. Any question, my friends? Any question about that? Yes, sir.
So like on the non-GFCI,
This one,
if you were to add another one, would you have to,
there's another one, right?
yeah,
And
would you have to,
so you're gonna
to
grab
balance
it
the load,
from
you have
here
to
and
splice
put it
it?
on this side, yep. And what's the neutral? And grab the neutral and bring it to the other side.
I guess I meant
Oh,
like,
they're upside down. That's why they keep confusing me. Why are they putting the neutral on the left? They're upside down. Okay,
what about this?
I'm used to the right. Okay, never mind. Go ahead.
But I thought you were saying something about the balancing of the neutral. Would you have to do that for the
It's a
Balancing of the
multi-wire.
neutral.
multi-wire? Okay,
It's a
never mind.
multi-wire.
It's multi-wire.
It's multi-wire, but
Never mind.
These are balanced, so if you have 5 amps, I mean, if the more you keep loading here, it could end up with unbalanced situation. So if this circuit right now is pulling 10 amps, and this circuit right now is pulling 5 amps, what do you think is going to go through the neutral? 5 amps, right? But you try when you try your best to put, like if you have 6 receptacles, you put 2 of them on one GFCI and the other 2 on the other GFCI. So if you have 6 receptacles in a kitchen, guys, how would you do a 6 receptacle in a kitchen? 2 of them must be GFCI, and the other 4 non-GFCI. So you put 2 on the first GFCI and 2 on the second GFCI, and give you a total of 6, right?
Okay.
And you keep here's 1, 2, 3, 4, and and so let's say we have 7 of them. Now I have no option other than making this is a GFCI, this is GFCI, and then this will feed this, and this have to be fed from somewhere. And then from here, here's the 2 loads, and here's my neutral, right? Common neutral, and the common neutral keeps feeding the load side, and from the line side, keeps feeding these. That makes sense. Any question, my friends? Multi-wire branch circuits, big deal. If my father-in-law can wire them, Spencer, there's no reason for you not to be able to wire them. Really not hard. This is typical for kitchen. Why do we have 2 GFCIs in the kitchen? Can I get away with 1 GFCI? I have to have 2 circuits. Not only I have to have 2 circuits, I have to have 2 circuits that goes through the countertop. They go through the countertop, must be at least 2 of them must be GFCI. Okay, moving on. Here's the wiring circuit that you guys were going to button around and wire it. Should we wire it? Should we wire it? Okay. Should we take 5 minutes break and let me just look at the way they want to wire it, and we'll wire it. All right. Okay. All right. Let's go. Oh, it took my. All right. Just before we start wiring it, we have to agree how they wired it. How they wired it, guys. Before we start wiring it, if you read through the description of the book, here's how they wired it. Because I can wire it any way, shape, or form based on this layout.
It's
The way-
operator.
The way they did it, guys, is this switch controls this light. This is a stand-alone exhaust fan for the kitchen with a switch integral to the unit. Stand as typical. Should have remembered that, as typical. These two cans were controlled by one switch right here. One of these switches here. That's how they wanted to do. I could do it any way or shape. And this track light is controlled by one switch here and one switch here. Okay? Everybody knows what the, and then this section here has nothing to do with what we're doing. This is going completely from a whole different,
So would that still be considered illegal?
a whole different,
Illegal.
assuming that there's a box here, assuming it's not a CAN box and the box is rated as, assuming that the fixture has a box that's rated as a J box. Let's assume that.
But if you're finishing the ceiling, how can you put a J box in?
Yeah. Well, this could be
Yeah,
a
you
surface
get to-
mounted fixture and underneath a box, right?
You can mount it,
Surface
you
mount.
can take a can
Yeah.
out and then have
Yeah.
a junction.
It's a J box. It's not part of the fixture.
Oh, okay.
It's not part of the
I was
fixture.
wondering.
It's not part of the fixture,
Commercial
is
ones
it?
Usually have,
Huh?
it's separate on the commercial ones, it usually is.
You
There's
don't
a
put it
separate little box on the side of it.
on the side of it. Well, but this is not a can. Let's assume it's not a can.
Well, it's not recessed.
It's not surface mounted. Yep.
We have eight
That's
watt-
probably what, huh?
We have 8 20-watt fluorescent lamps.
Fluorescent lamps.
They're fluorescent.
So-
lamps,
so surface
This
mounted.
is,
So it's
but
illegal.
yeah,
It's
so
legal.
it wouldn't be-
Surface mounted.
It's surface mounted, so you can.
You can surface mount it and there's a J box behind it. You can't use, guys, the confusion is you can't use a J box if it's part of the fixture. If the J box is standalone J box and you put the fixture above it, what's wrong with that? If the fixture is, the J box is part of the fixture, you can't use it as a conduit.
So you could pull it into a light fixture
Yes,
box.
yes.
And then hang the fixture and
Yes.
the light on it.
Absolutely. Okay, can you guys keep in mind, this is how they want it wired. Let's go wire it. Because you have to know how they want it to be wired. All right, everybody got that one? Let's go wire it. Ah, you guys are troublemakers here.
First, we don't talk enough, now we talk too much.
Yeah.
Make up your mind.
You talk.
All right, where did that go? Here, go, Chad, go. I want
We
my,
need versus done, and-
don't open that can of worm again. Okay,
Not gonna go there again.
we're not gonna go here. All right, let's establish the direction. I'm gonna bring, first I'm gonna just follow the way they did it, guys. So I'm gonna, let's establish the rules. This is neutral, this is neutral, this one is hot, this one is ground, okay? Establish the rules, before we do anything else. All right, I'm gonna go ahead and bring my hot. The way they did it, they brought their hot to the switch. Here's they brought their hot, oops,
I did
you
it, but
see
I
the
didn't
hot,
the way they had us.
they brought the hot to the switch.
I didn't look at the diagram.
Okay.
I just wanted to-
Can you guys see what it did? They brought the hot to the switch, and from the switch, what did they do? They went to the light, which is right next to this light. They went from this side to this side, and then with a neutral, which is blue, my convention for the neutral is blue, they came from here, they splice it, and they came and tie it to this light. Now this light is on. This light is on. Anybody have any problem with Chad? This light is on. This light is on. This light is on, right? All right, let's go get the neutral. Now let's follow, I'm just following the way they did them. Well, let's take the hot and the neutral to this fixture. I'm gonna get the neutral to this fixture right in here, because it's a neutral. Okay, and then they brought from here, also the neutral came from here to the neutral side here. They came the neutral to the neutral, and from here, they spliced the neutral and they went to this side of the neutral. So the neutral, I just brought the neutral, right? Let's go to the hot. See what they did with the hot. Now we said these cans have to be switched from this switch. So here's what they did. Here's what they did. They brought the hot. Here's my hot. Here. They brought the hot into this point. They didn't land it yet. It's not landed. See, we brought it just into the box and pulled the hot from here to just here. and they pulled it from here and fit this exhaust fan. Now this exhaust fan is on. The exhaust fan is on by itself because it has its own control. Okay? And then they pulled it back. They pulled the hot down into this side of the switch. I'm going to bring, what color? Black. I'm going to black. I'm going to use black as switched hot. And then they brought this one from here into this fixture and back again to this fixture. And to stay with the same convention, I want to use this one also, the same convention. I want to stay with a switched hot. My black is a switched hot. Can you guys see what I did? I brought the hot just here. The hot, split it, fit the fan, and then brought the hot to the switch, switched the hot, and brought it back to these two. Now these two cans are switched from single pole, single throw switch. Single pole, single throw switch. Single pole, single throw switch. Anybody has a problem with that? Mr. Erbab? Do you have any issues with that? Chad is giving an attitude here. Okay, I have to look at what then three-way switches. I'm gonna ignore. Okay, let's see what they did here. Okay, let's bring the hot. Let's bring the neutral because we know we need a neutral. I'm gonna go bring a neutral. I brought a neutral from this can directly to this can. I brought a neutral from this can directly to this can. Right? That's a neutral. Can you guys see that? To the track light. To the track light. Neutral to the track light. And I also brought a hot. To the track light. I didn't land it on the track light. I just brought it to the track light. And from the track light, let's do the, come on, who's this? Revit experts. Who cares about Revit experts? Let's let me just for 1 second, guys. I'm gonna go and grab the two three-way switches, just because I need one conductor going to the three-way switches from here all the way to this side of the three-way switch, and from here all the way to the other side of one three-way switches. Okay, so I established my three-way switch business. Now this here, I need a switched hot coming back. Okay, great, Chad. And I need a neutral is there. I need a hot. Switched hot coming back. All right, here's what they did. Do you guys agree with me that there is a hot here? There's a hot here. So what they did is they tied these two together. You have a problem with that? They tied them together. Now this three-way switch is hot. I energize the three-way switch. From the other side of the three-way switch, guess what's going to happen? From the other side of this three-way switch, it came and landed on this fixture. Now this fixture, I can turn it on and off, on and off. It has a switched hot and it has a neutral. Okay? It has a switched hot and it has a neutral. It has a switched hot and it has a neutral. And the other three, these two three-way switches and a light fixture, they need a neutral for it. Okay, so what do I have in this box? I have a switched hot coming back, and neutral is here. I need to bring down. I don't know how they did it with that. We're short one wire the way we are doing it. Right? We're short one wire. We're short one wire. I don't know how. Let's think about it, guys, one more time. If I brought the ground here and bring it back, that doesn't solve the problem for me. We're short one wire. We're short one wire. Okay, so let me just do it what I think it should be done. And so we brought this. I need the neutral, guys. I'm gonna grab my neutral. I'm gonna grab my neutral from here and land it in here. Land it into this switch. And from this switch, I'm gonna land it into this fixture. Okay? And so that's, I brought the neutral. The two three-way switches, it's gonna be a mess here, so you're gonna excuse me. Here is one, and here's another one. That's just between the two three-way switches, the outside, right? And then there is one switched hot coming from here, just landing here and going directly to this fixture, Up to this point, we're missing only one wire. And I don't know how would you do it. We're missing, everything is okay, except what are we missing? A hot, we're missing a hot. Based on the way they're showing it. So, you have to have a 4-conductor wire. Anybody can come up with a different way of wiring it based the way they are? Yes, sir.
Where's that red one going that just
This
stops?
thing? This guy?
Yeah.
And that's what I mean. We need to carry it with another conductor.
You can run to that to the 2-gang 3-ways, right about there.
2-gang here.
Yep.
Yeah, but then that would add another wire, which we have to. So I brought this hot now directly to here. Now we are good to go. Except how many? Yeah.
Then I think from there, how you have your travelers running through there.
Yeah.
They brought that switch top down to your 3-way below. With a single pole. Instead of tying the hot from the single pole.
They
brought
tied
the
it
hot
there. Okay, then.
It shows a 3-way going.
Okay.
Down there.
Okay. I see what you mean. Okay. I see what you mean. So this one is not tied together. I buy that one. I buy that one. This is a traveler that came over here. Which switch is it? And oh man, it's gonna be
It's gotta be a hot switch.
come over here. And but it has to be. We're still short one wire though.
Well,
That would be your hot. Not your
you have your
switch
2
top.
travelers and hot.
Genius. You're absolutely right. That would be my hot, stealing it from here, bringing it to here. Yep. And then the other wire, you don't need the hot to go. You're absolutely right. You're absolutely right. And the other one would be the traveler, which is this one here. Yep. I know it's a mess. Thank you. That's absolutely, that's doable. That's completely doable. They stole the hot from here. So there are 2 hots coming to this box. That's okay. Sorry guys. A little bit. Should we do it again? In this way you can get away with 3 conductors as they're showing. Otherwise, the way I was wiring it, you need another conductor. You can do it, but you need another conductor. So we have the 2 travelers. We have the hot coming from here. And okay, the hot coming from here, and then you still need to bring the hot though. You still need to bring the hot from here to this point, don't we? We still need to bring the hot to this point. But we still end up with 4 conductors though.
You don't.
We still end up with 4 conductors. We have a hot and a neutral and a switched hot. A hot and a neutral and a switched hot
Why do you need a neutral?
Between the switches.
for the light.
Between your neutral, between your switches, you don't.
No, but for this light. I need a neutral.
From your track light.
But yeah, but I need a wire for it though. I need a neutral.
3-way. 3 wires.
Yeah, I need a hot, a switched hot. Yep, and a neutral. Yeah, that worked. 3 wires. A hot to bring it to the switches, a switched hot to bring it back to the track light, and a neutral to share it with the outside light. We don't need the 4 wire. Will work. Hot to energize the switches, switched hot to bring the power, switch this fixture, and a neutral to share the neutral with that fixture. Okay, enough for wiring. These are, I mean, guys, as I said, there's so many ways of doing it. That's what you, when you start laying out your receptacles, as you said, this is the best way of doing it, is what they, I think what they did. What blew me a little bit is having 2 hots here. I thought, what if I can steal it from here? I guess I could have, but then I can't bring the hot back. I still can't connect it from here, and this will, yeah, this has to be switched hot though. You can't do it. Okay, enough. Enough of this. All right, let's switch track, guys. Yes, sir. No, not again.
I cannot see the way the wires are.
Can we wire it 1 on 1, you and I?
Yeah,
I'll
okay.
help you wire it. Let's do it
Yeah.
1 on 1.
I only could not see
That one?
these
No
two.
problem. I'll help you do it better than what we did even. Okay, lighting branch circuit, guys, for living room. Just quick analysis of that chapter, because I really want to keep going and to stay on track here. Okay, living room requirements, dimming, all this good stuff. I'm going to go directly to look at this. If you think that's not a mess, okay, look at this mess. Let's just analyze it, guys, like we do everything else. That you don't have to do it the same way. What they did, I think, and correct me if I'm wrong, I've been wrong a couple of times today. What they did, guys, is they brought the circuit over here, and we have a hot receptacle and a switched hot receptacles. We all agree with that. That's why we have these 3 wires over here. One of them to carry the hot, and the other one is to carry the switched hot, right? So we came over here all the way up to here, and we have a 3-way switch, kitchen 3-way switch, comes straight up over to the kitchen. And these cans, I know for a fact these cans are wired and switched from here, right? We agree on that one. These 2 cans are wired and switched from here. The 3-way switch, I believe, correct me if I'm wrong, it's switching the receptacles. So here's how the switch mechanism is. These are switched from this switch, okay? The track light piece of cake, Chad, the track light is switched from here. And all these receptacles, they want the 3-way. Do we have a 3-way switch? Where's the other 3-way switch? Dimmer, switching these. You can't switch receptacles dimmer. And this is why it's 3-way switch. Is there another 3-way switch sitting somewhere? 3-way switch coming over here. Yeah. So this one, and don't ask me why, and this one, they're switching the 3-way, the split receptacle, right? Brooks, that's what they're doing. They're switching with 3-way switches and 4-way switches, the receptacles. I could do it any way or shape I want it, but they want the 3-way switches to switch the receptacles. Okay? Okay, based on this analysis, are they doing it? Can we do it with the wiring that they have? I brought the circuit with hot neutral here. Why did they switch the 3 conductor here? 1 hot, 1 neutral, 1 switched hot. Returning back, so I came over here, the same thing all the way, hot neutral switched hot neutral switched hot to this point, right? And then between the 3-way switches, guys, I have 3 conductors coming from here, 2 travelers and 1 switched hot, 2 travelers, 1 switched hot, all the way to here. The switched hot is dumped across the switched receptacle, and so that's why we have the 3 conductors, the neutral, of course, and another hot that continues, another hot that continues through the other non-switch receptacles. Any question? And I have the hot and the neutral here. That's straightforward, guys. Switched neutral and switched hot. Any question about analyzing it? Really, this section is piece of cake. Hot neutral with a track light, hot neutral with a can light. The switches have two things. Have one hot, one switched hot, one neutral. And the relay switch, which is, you guys are looking at it, this big boy here, coming here, going all the way to here. This have a hot and a traveler 1, traveler 2. Actually, this should be a switched hot because the hot is in the other side. This is switched hot, traveler, the same thing, switched hot, traveler 1, traveler 2, all the way to here, right? The switched hot is dumped across here, and the hot to the receptacle is coming from here. There are 3 of them. Can you guys see that? Everybody see that or no? Can you see it? No? Everybody can see that? No? Okay.
That's pretty much it.
For track lights, guys, you can use track lights anywhere in the home to show things. The only thing I want to emphasize about the track lights, this item here. For track lights, for load calculation purposes, track light is part of the general lighting loads. You do not, track lights normally we allow 150, not normally, by code, 150 volt, guys, pierce for every 2 feet of a track light, except if they're used in residential. Then it's big fat 0 because they're part of the 3 volt ampere square foot for the residential calculation. 150 except if they're part of the residential. We use them as accent light, pro light at certain things, Chad's picture and so forth. Any question guys about the load calculation? Do we add volt amp for the track lights when we do the calculation? No, if it's in residential. Couple of track lights, hardwired. Dimming, a couple of dimming, guys. You can read through it. There's electronic dimmer and auto transformer dimmer. The most common dimmers right now is the electronic dimmers. You need to pay attention as you put your dimmers in 2 things. Number 1, are you dimming fluorescent light? Yes, your dimmer has to be dimmer, fluorescent light rated dimmer. And I have a couple of pictures to show you. They have to be the right voltage, the right amp. Missing anything? And there's a few things how the electronic dimmer guys take the voltage and chop the voltage to reduce it when it dumps it across the light. Couple of pictures of dimmers. Here's a couple of things about fluorescent dimmers. I have really nice pictures that you guys I want you to look at. But fluorescent dimmers, you can buy them that they can get you from 0% of light all the way to 100%. You can have another level 10 to 100, or you can have either 100 or 50, one switch, 150, or and you can get them in an optional way. Yes, sir.
Are they 100% to 1% because they have to have the 100% turned on?
100% is completely full.
But I mean, do you have to do that to get the arc in the beginning?
The 1%, the 1%.
No. Do you have to be 100% in the beginning to get the arc?
I don't think so. No. You can start with 1% if it's rated for 1%, and you still fire it. You mean, can it fire if you put it at 1%? It should.
Can you just go to 1%?
And it should fire enough to get you the arc, to get you the 1%.
So why don't they make all fluorescent setups like that instead of having you have that all that voltage to get going?
I don't know.
You're an engineer, Chad.
I should know.
Good.
But you're going to keep this question though for you, the lighting experts. We're bringing a lighting expert that talks a lot about dimming for commercial next quarter. So you ask him why can't they make and I'm not a lighting expert. So but I know you have I know they wire it. You have to have enough voltage to start the arc. How much big of a voltage? If it's rated for 1%, I assume if you give it 1% worth of voltage, you should start. But this is actually light level. Doesn't have to be 1% because that's 1% light level. It could be 10% voltage.
40 volts going 2.4 volts. Right?
This is 100 to 100%. This is light level. Light level. Light level is different than here's what it means. If you have 1,000 lumens and it's 100%, 1%, that will be 1% of 1,000 lumens. What you're gonna get. How much voltage is a whole different story. How much voltage is a whole different story. Good one, bud. You got your 10% engagement. Okay, ballast. Here's an interesting situation. I don't know how many people do it. They recommend that you burn the fluorescent light for 100 hours before you dim it. Burn it, get it up and running before you dim them. Obviously, if you have a ballast that's made for single lamp, don't go through a two lamp say, well, here's a lamp that rated for single. When we go into lighting, guys, you're going to get into sizing the ballast, and we get into a lot of details. And if your fixture is one lamp fixture, you size a one lamp ballast. Or they can buy a ballast that can run with one lamp, two lamp, three lamp, or four lamp, or even six lamps. You know what I mean? So you have to match the ballast to the maximum number of lamps that you can drive out of these ballasts. Here's an interesting situation. If you guys look at this fluorescent wiring between fluorescent rated ballast, fluorescent dimming circuit, the ballast have to be a dimming ballast. Unlike incandescent lights, where the incandescent lights is just a wire, and you heat it and you reduce the voltage, it reduces the light. These guys, you have to have a ballast that's actually rated to be dimmed, and you have to have a dimmer. So look at they have the neutral. You always need a neutral. You always switch lead and control lead. There's a switch lead and control lead going to the ballast. There are three wires. Unlike other ballast, guys, where you can, if it's another ballast, like for incandescent lamps, you have two hots. One hot, switched hot, and one neutral going to the light. Here you have to have a controlled light so that these can talk to each other and coordinate how much voltage needed to fire, like my friend said, to fire this lamp. Through the control wire, they have to coordinate how much voltage needed to fire this lamp, and of course switched hot to control it. So we all know that all outlets have to be arc fault circuit interrupters, except in places where it has to be GFCI, including lights, right? That's not a common knowledge now. I think I have a couple of other pictures that I thought you guys interesting probably. We talked about the lighting. I'm not going to wire this not in a board anyway. All right, why am I not moving? Let's close it. Okay, my computer. All right. Did you do anything to my computer, Brad?
Yes.
Did you put your spell on it? Okay, here you go. You're not put a spell on it or anything, man. It just was sleeping. Got that. A couple of things, guys, about construction. You're not an electrician, but they don't want you to wire it this way. Look at that. Either you put it in between. Look at that dimension that they suggest to put the track lights versus mounting it. Different ways of mounting the track light. Is there?
There was one thing in the reading that said that you always, or maybe it was a question. It said you always have to have the home run or the conductor come from the end of the track light.
If it's rated the end, you can bring it wherever the box is rated for, like here, or from that area, wherever you have a termination box rated to it.
Yeah, but they make them so that you can do it from the center and whatever.
You can. I believe they can make them in
Ones that
any
are adjustable.
shape or form
Okay.
in terms of bringing them. Lighting circuits. You need. Let me see here. Okay, we have the track lights. Anybody wire, guys, three-way dimmers? Anybody wire three-way dimmers?
Yes, so.
Three-way dimmers? They can dim from one location, but not from the other location. Confusing as hell.
They have the diagrams and things, so really hard to follow. I still have
If it's an incandescent light, this is a really good one, guys. If you're dimming an incandescent light, all what you're doing in reality is really just reducing the voltage. So if this is running at 120 and you give it 60 volt, it will give you 60 volt equivalent light. If you give it 20 volt, it give you 20 volts. So it's really easy incandescent lights. When you get into fluorescent lights, it's a different animal. Here's a fluorescent light where you have to have the control. Remember, we have to have a control wire. We have to have a control wire, two lights driven by the same ballast. You guys have that one, right? So here's my on-off. Here's my controller. And look at how we have we wired them with 3 wire. One is neutral always, one switched hot, and the other one is a controller to talk between the ballast, the 2 ballast, and the controller right into the dimmer. You guys can research and see how they talk to each other, reduce, chop the voltage, and so forth. All what we care right now is you have to have a ballast that you can dim and a fluorescent rated dimmer. These 2 have to talk to each other. So if I want to dim this fixture, no problem, Chad. I have to specify a dimmable ballast with it, and I have to buy the ballast have to be dimmable, and the switch, the dimmer have to be rated for fluorescent. You wire them with these 3 wires, hot, switched hot, and a control wire, and you get your system up and running. Any questions guys about that? Questions? I thought that will help you with when you lay out your wires. Anybody use dimmers and fluorescent in the project? You did?
Oh, not in my project work.
Here's what we talked about, these wires, couple of dimmers. And who's going to give me the honor of doing this? Wiring.
We
Anybody wants to do that?
did.
Not today. And by the way, if anybody wants to go through them, guys, I'll be more than happy to go over it one-on-one, but we're not gonna. The last chapter that I want to guys quick just scan through it before I ran of my. The only thing in chapter 13 really I want you guys to know is 2 things. Number 1, track lights when installed in residential do not give 150 volt ampere 2 feet in residential. Commercial, other than residential, yes, as you do your calculation. And we're going to go over this in calculation, guys. We have it. Number 2, as you put your lights and you dim them, 2 things you have to pay attention. What type of light, and does the light, the dimmer, match the light? If it's incandescent, no problem, bring it on. If it's fluorescent, you need a specially designed dimmer to dim fluorescent, number 1, and you need a specially designed ballast that drives the fixture to talk to the dimmer. 2 things. The ballast have to be capable of being dimmed, meaning have an extra wire on it. You have to have an extra wire, the control wire, and the dimmer have to have a capability of dimming it, means have another extra wire so the dimmer and the fluorescent can talk to each other through 3 wires. That's all what you need to know. The layout of the living room, you can lay it out in any way, shape, or form you want. Any questions guys about chapter 13?
Can you repeat that thing about the track lighting in residential?
The track lighting in residential, when you do volt amp calculation, meaning how much volt amp I'm going to allocate for this track light, big 0.
Nothing. But
Nothing.
commercial, you do.
In other than residential, commercial, industrial, environmental, is it environmental building, government buildings, schools, you give 150 volt amp for every 2 feet. We're going to go through this guys in calculation. It's coming. Okay. That's basically it. Am I going too fast through these chapters, guys? No, too slow even? Too slow? No, not too slow. The last one is 2-page chapter, talks about the study room. Anybody has a study room? Study room? You have a study room? What's the difference between study room and office room?
No class.
Office, study room, call it office room. Okay. The only thing they have is the concept of, remember guys, we talked about different type of lights. We as engineers, we always care about the general lighting system. General lighting system, right in the ceiling, done. There's multiple other lighting systems. You have security system, you have valence system, ascent lighting system. There are multiple systems that you can use to throw lights at different things for different task lights, so I can do my work. They have a valence lighting system behind the curtains here, just for the heck of it. And they have receptacle switches, and since this is an office, and Muhammad, my friend, in your office, I assume you have multiple computers, you have equipment, right? So what do you need every time you have electronic equipment? What do you need to protect the electronics equipment from? surge protection. Surge protection. Surge is coming from lightning hitting the transmission line, going right through to your house, or from somebody transmission line being switched from A to B, or from your furnace kicking in. Internal, your furnace kicking in and throwing some polluted signal on the network in your house. So long story short, you end up with the surge protective devices that you add to your receptacle. Either you buy a receptacle surge protective devices, and most of us have a standalone plug-in surge protective device equipment. Here's how they wire it. Okay, anybody want to give a guess what they're trying to do here? I can tell there's a fan and a light. Why do you think they have 3 switches here?
Switch. And a light.
You can put the fan on light. So I know for a fact, just by looking at it, I need two switch. There are 2 switches, one for the fan and one for the light, right? There's 2 of them, one for the fan and one for the light. That's cool. And then they have 3-way switches, 1, 2, 3-way switches. I know for a fact that this light and this switch are brothers and sisters. Is that term they use? So controlling each other. And what do you think the 3-way switch is doing here? The 3-way switching. What does they love these switch receptacles. Anybody did switch receptacle in the projects? They love it in this book. They have a 3-way switch that controls receptacles. Okay? So if you look guys right in here, this is to switch these ones to a different color. This 2 is to switch all these receptacles. Okay, what did they do? They brought a circuit, guys, circuit A21, hot neutral to the first receptacle. Why did we switch with 3 conductors here?
Switch.
Hot, neutral, switched hot. And they continue to go. When they reach here, they tap the hot and the neutral, brought it to the light, re-identified the neutral, right? Coming down as a switch, as a hot, and took the other conductor and switched hot to the light. Excuse me. And then they went through all these and fed them all the way. Why do we have 3 wires here? 1 switched hot, 1 neutral. Can you guys read that when you look at them? Am I repeating myself too much? Can you read that?
Yeah.
You should be able to, not you. Did I ask you?
I think
Can you guys, everybody can read that as you look it through them? Every time you see 3 conductors going between things, always think, oh, maybe they're carrying another extra hot for switched hot. If you want to work as a designer, drafter, guys, you don't need to know that, really. If you want to work a project manager, estimator, wires in between, how are you going to estimate the wires if you don't know how many wires in between them? It really, it defeats the purpose. Okay, we have indirect fluorescent light used behind the windows, guys. Window as a valence board. We can dim them. They're dimmable. They decided to do it this way. Here's what we're looking. Anybody ever installed or seen them? Seen them?
Valence lights?
Yeah, valence light.
Yeah.
What did you use them? Beauty? Just
I, for,
Just-
people want them for valence lights.
okay.
And they're formal room uses.
Okay. So dimmable. Talk about TVSS, guys, which is Surge Protective Devices. They changed their name in the NEC code book to Surge Protective Devices now. We talked about this one. They suggest, if you read, guys, if you have an office, they always suggest quadruplex. What's a quadruplex? We have a quadruplex here. When you have 2 duplex side by side, two duplex side by side, it comes really handy. We use them a lot in commercial. We have 2 duplex side by side. That's quadruplex. What does that mean, guys? A lot of places to plug in, number 1. And in commercial, we bring 2 circuits to the same location. 1 to 1 duplex, the other one to the other. So you have not only multiple locations to plug things, right? But also gives you more power because you have 2 circuits now. So that's what they suggest if you want to turn your bedroom or something into an office. Don't forget that everything in this area has to be arc full circuit interrupter. Starting January 1st, 2014, if you change your receptacle there, it has to be arc full circuit interrupter. January 1st, 2014.
Have you even seen the receptacle yet?
No, I sent a picture of it.
So they're giving me some 14.
They're giving you until January 1st, 2014. If you don't like it, move to Wisconsin. Oh, that's a big one. I think they modified the. So we talked about that one, talked about one, that one, that one. Okay, I have time. I want to wire this. I do have time. Let's go wire it. Anybody want any volunteers to wire this?
We did.
I don't know.
I'm hesitating here. You can help me. You can help me as we wire. Okay.
Yes, sir. Volunteer.
Let's go ahead, guys. I know you can do it. I have no doubt that you can do it. But can you guys be with me? Let's wire this one. Let's establish our.
That's where you
Our-
use smart wire.
Before we wire it,
They let us come up and move around.
before we wire it, let's establish our criteria. This is a hot.
That's circuit number 21.
The circuit is a hot. This is a switched hot. Okay, that's a criteria I'm using. This is a switched hot, or you know what, a hot. Let's use the red as switched hot. Switched hot. We don't have a whole lot of switched hot.
Yeah, but you need it.
Okay, let's use a switched hot. Okay,
Blue.
and let's blue for the neutral because we live in Europe. Blue for the neutral.
Is that what they use?
Yep, blue in Europe is neutral.
Oh,
It's not green. And let's use the green
for hot.
for ground.
What do they use
What?
for, what do they use for face colors then?
Okay,
Hot too.
a brown,
Black,
red.
blue.
They use white as yeah.
They use white as a third face.
It used to be white. They changed it. They changed it to blue. White in Europe used to be the neutral. They changed it just in I think in
So they
2001
use
or
their
two.
face colors, they use usually black, red, blue.
Because when I was wearing in Jerusalem, we used to wear the neutral as white, and then I went to visit one more time, and they're switching to blue is neutral. Okay. Is that enough, buddy? Okay. Let's go. Let's go ahead, guys, and wire that.
Blue orange yellow. Oh,
Brown.
Let's first of all let's bring which receptacle is where. This one
the home
is
run.
the closest one. Okay. Let's go bring the neutral. Let's go bring my neutral. My neutral from here to here. I brought my neutral from here to here. Anybody has a problem with this? And then I brought my neutral back to here, right? That's the second receptacle. And I'm going to bring my neutral from here into here. Anybody has an issue with this? That's the second one.
Now to
And
the
I'm going to
bottom,
bring it to the lighting. They went from here
to the light,
first to the light with a neutral, first to the light,
and there's
okay, and then they went from the same location
receptacle,
to the other receptacle. Yep, from the same location they went to
down.
this
There,
receptacle. Okay, and from this
Up
receptacle,
to the top.
no,
Yeah.
1 second. Let's just keep going receptacle to receptacle first. They went also from here to here with a neutral, and from here to here with a neutral. Okay, so I brought the neutral all the way, and they also brought the neutral guys from here, and they set it right in this box. And that's what they did. They set it in this box, or one of these boxes, and then they drag it from here all the way to this side of the fixture and this side of the fixture. This is my neutral. My neutral is going all the way and feeding my fixture. Am I missing anything?
The balance.
The track light. They brought the neutral. Look how they did the track light. They brought the neutral from here. They brought the neutral from here all the way back to the track light. Okay? Or is that the balance light? Okay. Any questions about the neutral? Neutral, did we do any, Brooks, did we do it right? Keep an eye on chair today. I didn't have
There's a
enough
break
coffee.
in the line though.
Where's the break? No.
Break.
Oh, come on. This one here?
It didn't work.
Alright, now we connected it. This is the neutral, guys. Now let's go bring let's go bring what? The hot. Now let's go bring the hot. We're gonna make the hot. What did we say? The hot is black. So I'm gonna go grab the hot conductor from here. I'm gonna grab my hot conductor. The outside receptacle is always hot, so I'm gonna grab my hot conductor from here, land it on this side of the receptacle. Which side are we gonna keep hot all the time? The top. So then I'm gonna grab it from here and come over to this side. Isn't that what we did? Right? And I'm gonna grab it from here, go to this.
That one actually
it
is
upside
the
down.
outside receptacle, so it's hot on both sides, the first one.
The first one, the second one. Are they switching?
Yeah, second switch.
Switch. We're switching the top. We're not. We are keeping hot the top. The second one here is not switched, is it? This one is not switched. So I came from here and I landed right in here. Anybody has an issue with that? No? Okay, and from here I went to, here's what we did. I went from here to the lighting fixture. Out of the lighting fixture, I went to this side of the switch, and I brought the switched hot back to this fixture. Anybody has an issue with that? Now this fixture is being able to be switched. It looks like it's fixed here. Let's just do it, make it clearer if I can. There you go. So I brought it here, and from here I came out of here, and from here I brought this one here. Does that make sense, guys? So now this fixture is hot. We're going to continue with the hot, continue with the hot to the other switch, continue with the hot to the other switch. We are leaving, bringing it to here, bringing it to here, and bringing it to here. So we brought the hot, no separation here. So we brought the hot all the way, and then they brought also the hot, and then we brought the hot, guys, and we energized all these switches. They brought the hot from here, they stalled it, and they brought it here, here, to energize these two. Energize these two. Where's the other one is going? Oh, the balance light. And they also energize this one here. And I believe
Dead end, the three-way's dead ended, so we're doing it.
also energizing. They're energizing this too here. Okay? So they energize, here's the hot guys going energizing all the non-switched, the hot part of the non-switched part of the receptacles, and energize the switches. I energize the switches. Okay? Now to make this, any question about the hot and the neutral? I want to go grab this, grab the switched hot now. Now let's start with this fan, guys. I have two switched hot. I want to bring one from here directly to here. Well, which one is the fan? It doesn't matter. They're not labeled here. So this is here. And the other one came from here back again to here. Anybody has an issue with that? 3-wire conductor going to the fan light combo. To the fan light combo. Muhammad, my friend, any question about that? No? Cool? All right, so we're cool. And then they brought, for the valence light, guys, they brought the hot from here all the way and landed on this light. So that hot is controlling the valence light. Where's the neutral that came with it? That is a neutral. Can you guys see that there's a neutral coming with it? Okay. What else do we need? We're missing two travelers between the two hots. So I need a two traveler. Let me just move them away from the system here. Here's one traveler coming here, and another traveler going all the way to here. These are my two travelers. Okay. And also, I need a switched hot coming here and landing in this box. Not doing anything, just landing there. That's my switched hot. And I'm going to take this switch hot, right? I'm going to take this switch hot and loop it all the way to every receptacle. From here, loop it all the way to here. And then from here, loop it all the way to here. See how I'm doing, what I'm doing, guys? From here, come over here. Any switched receptacle have to have it. And from here, go all the way to here. I'm done. I'm sorry, spaghetti. Let's see how many lights do we have. So how many wires do I have here? 3 wires. How many wires do I have here? 3 wires. How many wires do I have here? 3 wires, right? How many wires do I have coming to this boy here? 3 wires. How many wires going to right here? 2 wires. Where else? Is it 2 wires here? 2 wires here. 3 wires. What else? 2 wires. And I came from here to here. It's going to go from here, another 3 wires here, and another 3 wires here, right? Can you guys see it? I'm not going to put the ground. Otherwise, the ground will. Ground is just another green wire that's going to each and every one of them.
Don't need it anyway.
Huh?
Small.
Is that?
Looks like my
I'm
brain.
slightly colorblind.
Is that?
Don't need it anyway.
Is this hard?
No. It's not hard to do, it's just hard to follow.
Hard to follow my directions.
Do you have the noodle? Not the noodle.
You have the noodle.
But if with the color coding there, can you look at the green, like the green and not the green? Can you look at the blue and know that these are neutral?
Yeah.
Just the blue. And look at the red. These are either travelers or switched hot. Switched hot, and let's add also next to them traveler. Travelers. And the blue, what did it say the blue? Neutral, and the black is the hot. Any question, guys? You wanna go wire in our lab? Yeah. As I say, guys, if you're a drafter and you really don't want to get into it, that'd be good. But the more you know it, the better you will be. It helps you understand how the system is put together. It is a mess. Brooks, can you make it better than that for us? In the end of a mess. Yeah. When you wire it, it's not that messy though, because you're going.
I think just the way they have it set up on the page.
Yeah,
makes it-
They're setting it up as exactly as it's going to be in the room. I can set them up in a much better way to make it easier to draw them. Any question, my friends? Any question for Chad? Mr. Rebab, we can wire it one-on-one, man.
Tomorrow, I thought 7 and 8 were due for homework. Awesome.
Only 7.
Oh,
Did I kill you with these homework, guys?
that's.
Oh, dear.
I got scared.